Let's start this more systematic analysis of indeterminate forms by starting with the case that we've already seen before, and that is the situation where we end up with a number over 0 from our limit. So in this situation we have the limit as x approaches something of f of x, and by the way, in this situation our c is going to be a finite number, and let's say that we end up with a form of a fraction where the numerator becomes a number that is not equal to 0 while the denominator is approaching 0 itself. And in that situation, we know that we end up with a fraction which becomes as big as we want in an unbounded way, and therefore either the limit as x approaches c from the right and or the limit that as x approaches c from the left are going to be infinite. But you'll see what the problem is and why we need to go a little bit more into details, and that is that there are many possibilities. We can end up with the left limit being infinite, the right being not infinite, or one being infinite, the other being finite, or all kinds of other situations like this. So when that happens, what we can say is that definitely we have vertical asymptote. We know that at least one of the two sides is going to go to infinity. So we can guarantee a vertical asymptote. But what we need to do is we need to look at the one-sided limits separately in order to determine exactly what is happening and what is the pattern of the function around the vertical asymptote. So again, just do remember that in the case of number over 0, the two one-sided limits need to be analyzed. Let's look at a little bit more of a more interesting case, and this is a case that we will address with the factor and cancel method, which is called this way, of course, because it works by factoring and canceling. When does that happen? Well, let's say that we have a limit as x approaches c of a function, and c here could be either finite or infinite. And let's say that we end up with something of the form 0 over 0 or infinity over infinity. So what does that mean? Well, first of all, in the first case, it means that we're trying to divide a small quantity by another small quantity, right? And anything can happen in that situation. The two small number depends on how the two small numbers are related to each other. The top one could be much bigger than the bottom, creating a large limit or even an infinite limit. The top could be smaller than the bottom, and in which case you end up with a very small number and so on. So we don't know, it's an indeterminate form, but we're trying to figure out what it is. And the same thing in the situation of infinity over infinity. Ratio of two large numbers, it depends on how they're related to each other, what kind of situation will happen in the limit. Okay. But either way, we'll notice that if we have that situation, that means that there may be a common factor between the top and the bottom. Both are going to the same place. The numerator and the denominator are both going to 0 or are both going to infinity. They must have something in common. Not guaranteed, but there may be something in common. So what we're going to do is we're going to look for this common factor that they have, and once we find it, we're going to cancel it. Of course, using proper algebra. We're not just going to throw it away like garbage, but we're going to try and cancel it by division in a proper way. Now, when that happens, if the limit exists, if we're by doing this procedure we end up actually with a finite limit, then if c is a finite number, that means we're dealing with a single point whole, because the limit exists but the function does not, because of course we cannot divide 0 by 0 or infinity by infinity. On the other hand, if c is an infinite plus or minus infinity, then the presence of the limit tells us that we're dealing with a horizontal asymptote. Now, there is another method which is related to the factor and cancel, and that means that we're still dealing with a situation of a 0 over 0 and occasionally infinity over infinity, although less commonly. But let's say that factoring is difficult. Remember, in the factor and cancel method, we're supposed to factor so that we can cancel. But sometimes the factoring may be difficult. So we can take this roundabout way. So what we can do is we can try to expand the sum products or powers in the top and or in the bottom. And we do this until the formula becomes easier enough that we can actually go back to factoring and canceling and therefore computing the limit. So this is really sort of a sub case of the factor and cancel method. So we have some other cases to consider, and that will be done in the last video.